Okay, in this video, I'm going to find the inverse of this matrix right here using both methods. If you are confident that you know both methods, then you do not need to watch this video, but if you would like another example, I'm going to find the inverse of this matrix and give you another example. So here we go. Let's use method 1. And remember, in method 1, we use the determinant and we multiply a scrambled up matrix with 1 over the determinant. So the determinant of matrix E, what does that equal? That equals 7 times 3, which is 21. And then we're going to subtract from that the product of these two numbers, which is 20. So our determinant of matrix E equals 1. So now let's find the inverse of matrix E. It is 1 over the determinant, which is 1, multiplied by the matrix. We switch the positions of the 7 and 3, so now we'll have a 3 here and a 7 here, and we change the sign of these two numbers. So instead of a positive 4, it'll be a negative 4. Instead of a positive 5, it's going to be a negative 5. Then we multiply the matrix by the scalar here, which is really only a positive 1. So the values in our matrix do not change, and our inverse matrix, the inverse of matrix E, is 3, negative 4, negative 5, 7. So let's go ahead and find the same inverse, but using our second method. The first thing we would do is set up our matrix and append to it the identity matrix. We're going to try to eliminate this first. So it looks like in order to do that, I am going to multiply my bottom by a positive 7 and multiply the top by a negative 5. So let's go ahead and do that math over here. Negative 5 times 7 is negative 35. Negative 5 times 4 is negative 20. Negative 5 times 1 is negative 5. And negative 5 times 0 is 0. 7 times 5 is 35. Then we have 21. We get 0. And then we get 7. And when we do our math, we get 0, we get a positive 1, a negative 5, and a 7. And since we were trying to eliminate this bottom number here, we're going to replace the bottom row with our new row. We have 7, 4, 1, 0, 0, 1, negative 5, and 7. So I'm going to draw my line. The next location we're going to try and get rid of is this number right here. And it looks like it should be fairly easy. We're going to multiply our bottom row by a negative 4. So let's do the math over here. When we do that, we get a negative 4, a positive 20, and a negative 28. And when we add, we get a 7, a 0, 21, and a negative 28. And since we were trying to eliminate a number in our top row, we will replace our top row with our new calculations. 7, 0, 21, and negative 28. 0, 1, negative 5, and 7. So again, our end result has to be an identity matrix, and that means we need 1s along our diagonal and 0s everywhere else. We'll need to divide our very first line by 7. And when we do that, our end matrix looks like 1, 0, 3, negative 4, 0, 1, negative 5, and 7. And our inverse matrix is this. The inverse of matrix E equals 3, negative 5, negative 4, and 7. Hope this additional example helps. And you'll notice before I sign off that these two inverses come out to be the same, so either method works.